Predicting synthesis reactions. Synthesis reactions involve combining of two or more compounds to form a more complex compound. As you can see, A plus B is AB. That's the simple form of predicting synthesis reaction. The criteria is to have cation and an anion, or both nonmetals. First step is to write the reactions with the state of matter. The second step is to cation, cancel, and cross. The third step is to add the state of matter, and finally balance the equation. Now let's go try it here at problem 1.
So here we have tin and bromine. So you start off with writing your reactants with the state of matter. So it would be SN for tin, which is a solid, plus bromine, which is a diatomic, which is a liquid, and then an arrow. And as you can see, that is step 1 of our steps. Now we come back and we do the cation, cancel, and cross, which is SnBr4. And that is a solid. And on predicting synthesis reactions, unless otherwise stated, it is always a solid. Then we have to go back in and we have to add the state of matter to the end, which we already did, and as I said, it was already a solid. Next we go and balance the equation. So that would be adding the 2 to bromine, which is a diatomic, to make it equal on both sides. Now we'll go to our second equation. So first, again, we write out our reactants with their states of matters, which manganese is Mn, which is a solid, plus antimony, which is Sb, which is a solid, and we add the arrow. Now, as you can see, manganese, as you know, is a metal, and antimony is a metalloid, which means that it has to be no reaction, because it does not fit the criteria. So now that we're done with that one, we can go to our third reaction. Again, we write down the reactants, and sulfur is a diatomic, which makes it S8, and it's a solid, plus carbon, and that's a solid, and we go and we form the arrow. Next we put our product, which is CS2. You have to make sure that we put our most electronegative first, which would be carbon, and then we put down sulfur. Next we balance the equation, so we make it 4, because we have to make sure that 2 times 4 is equal to 8, so we can balance out the sulfurs first, and then we add the 4 onto the carbon. And that is predicting synthesis reactions.